Nobody believed the sky could change in a single day. Then Object 4, I/ARC, appeared, and everything that felt permanent began to wobble. In less than 2 days, this ancient traveler ripped through every expectation astronomers had about interstellar visitors. What started as a faint, unremarkable blip in the long archives of survey telescopes erupted into the kind of event textbook authors will struggle to explain. Teams that map the heavens for a living abandoned routine observations. Control rooms turned into war rooms. Specialists who had spent decades perfecting predictive models watched them collapse like brittle ice under pressure. 4I/ARC had been cataloged as an interloper moving on a predictable inbound course. Its incoming velocity matched expectations for objects that wander between stars. Then, without warning, it executed a maneuver that could only be described as intentional. Over the course of a single rotation around its axis, its trajectory shifted by an angle no natural object should produce. Instruments measured accelerations that implied forces equivalent to multiple nuclear engines, firing in perfect synchronization. There was no plume, no expelled mass, nothing visible to explain the push. It was as if a silent hand had grabbed the craft and steered it. By dawn, observatories on every continent were streaming raw telemetry. Veteran astronomers, the kind who rarely lose their composure, began openly arguing in exhausted whispers. The world watched as the most trusted simulation suites failed to reconcile what telescopes kept reporting. The object measured roughly 12 kilometers across. It moved at velocities that made orbital planners recalculate in real time. It was not debris. It was not a comet. It behaved with a deliberateness that suggested systems and purpose. Early spectral reads surprised everyone. Instead of the expected ice and dust signatures, 4I/ARC emitted spectral lines consistent with highly ordered metallic alloys and complex polymers. Abundances of rare isotopes made geochemists shake their heads. Surface imaging revealed patterns that were not erosion. They were not random fractures carved by cosmic radiation. Instead, the photos hinted at repeating geometric motifs, tessellations on a scale that would dwarf any human engineering project. Magnetometers registered field strengths that overwhelmed their calibration ranges. Regions around the object showed organized magnetic flux lines, forming as if an engineered field had been sculpted to cloak, communicate, or manipulate local space. Radio arrays began to pick up transmissions. At first, they were dismissed as interference. Then pattern recognition algorithms started to light up. Repetition, prime number sequences, temporal spacing that mirrored mathematical constants. Someone joked that the universe had finally left us a note written in pencil in mathematics. When a coordinated team at a major northern hemisphere array cross-referenced the signals with optical events, a chilling conclusion took hold. The bursts were not ambient noise. They were directional. They contained layers. One layer seemed navigational, referencing pulsar timing beacons that any advanced navigator could use as a cosmic compass. Another contained predictive models for local plasma density, solar wind evolution, and magnetic reconnection events with levels of accuracy that made space weather forecasters stare at their monitors in disbelief. A deeper layer hinted at algorithmic constructs so abstract they read like compressed mathematics instead of language. Talking heads in government science briefings clung to conservative interpretations. Natural explanations were framed, debated, and reshaped. Sublimation of exotic ices under high photon flux. Spontaneous phase transitions in materials formed under interstellar conditions. Strange gravitational interactions with exotic dark clumps. Each theory required assumptions that strained more established physics than it replaced. The more data accrued, the less comforting the naturalist arguments became. What raised the level of alarm, beyond oddity, was context. Analysis teams discovered archival records, weak background signatures embedded in the transmissions, pointing to other similar objects. Patterns in the navigation layer traced routes through sectors of the galaxy where no survey had reported massive stellar collapse or visible catastrophes. Yet the routing suggested the objects were not explorers. They were paths on maps that looked suspiciously like evacuation corridors. Whoever or whatever had launched these constructs seemed to have anticipated long-term threats and seeded the galaxy with silent couriers carrying instructions. Cryptanalysts brought in from multiple universities, and intelligence agencies began peeling back layers. Their breakthroughs came in the middle of the night, hidden within the navigational scaffolding, in sections that at first appeared as noise, were engineered redundancies containing survival protocols, not just propulsion schematics and shielding formulas, also manufacturing tolerances for habitats, energetic requirements for sustaining atmosphere in artificial enclaves, and resilient waste recycling architectures, optimized for long-duration survival. There were blueprints for technologies that would push the limits of contemporary engineering by generations. Then came the most unnerving discovery. Embedded within one of the deeper shells were sequences that predicted the dynamical evolution of certain stellar neighborhoods with a chilling specificity. They forecast where high-energy events would erupt years in advance. The timelines were not vague. They were measured in decades. According to the decoded data, several regions of the galaxy were on courses toward destabilization from processes that would render planetary systems untenable. The data did not couch these predictions in academic hedging. They were engineering grade warnings. The senders had run countless simulations and built escape plans. They apparently sent what they could and hoped others might reuse the knowledge. International reactions split along familiar lines and newly emergent ones. Scientific communities pushed for transparency and open access. Many governments moved to classify the most sensitive parts. Instruments were suddenly off limits. Observation windows were canceled under the guise of maintenance. Leaks started to appear almost immediately. Portions of decoded archives found their way onto public networks through anonymous channels. Amateur radio operators worldwide reported intercepts of the same structured transmissions, proving the signal was not restricted to classified ground stations. The struggle between secrecy and public knowledge fueled overnight communities of citizen scientists. Open-source decryption projects formed with a ferocity and discipline that matched any established lab. They cross-correlated data with publicly available observations, producing refined models that forced official agencies to respond. Pressure mounted on policymakers to justify withholding information about an object that might contain knowledge central to long-term species survival. As 4I/ARC drew closer to perihelion, its activity increased. Radiative output in certain infrared bands rose in predictable ways. Surface features altered at rates suggesting internal movement. Instruments aboard a number of near-Earth and Mars orbiters reported transient electromagnetic spikes coincident with these morphological changes. Spacecraft engineers worried about induced currents and potential damage to sensitive electronics. Mission controllers ran simulations to determine whether proactive shielding or orbital adjustments were necessary. Some agencies quietly repositioned assets. Other agencies publicly denied any change. Parallel to the physical concerns, emerged a profound existential debate. If these artifacts were carriers of survival knowledge, who decides how it is used? Are such resources the common heritage of an intelligent species on a planet like ours? Or does the responsibility of advanced governance demand staged release to prevent social collapse? The arguments were not purely academic. Economists predicted market panics if the public learned that practical steps toward interstellar migration or large-scale habitat construction were feasible, but centuries away in cost. Philosophers warned of cultural destabilization. If certainty about the fragility of planetary existence became public without practical mitigation options. Meanwhile, researchers refused to stop being scientists. Through careful coordination across national boundaries, a consortium of telescopes and space assets began a unified observation schedule. High-resolution imagery streamed into shared databases. Spectrometers, magnetometers, and radio arrays pooled their raw measurements. The goal was simple and urgent: extract maximum reliable information before the object reached the part of its orbit where solar glare would blind many instruments. For a number of telescopes, that window meant weeks. For some, mere days. What emerged from the collaborative effort was sobering and electrifying at once. The object was not merely a relic. It was an archive civilization shaped into a machine capable of long-term operation through exposure to interstellar conditions. It encoded cultural artifacts alongside technical manuals. There were rhythmic emissions that matched complex musical structures. There were compressed pictorial matrices that, once expanded, suggested recorded observational logs, star charts annotated in a language that translated to physical constants and geometric relationships. It became clear that whoever constructed these messengers cared about transmitting knowledge in ways that could survive cosmic timescales. Debates over motivation intensified. Some researchers argued the artifacts were purely utilitarian, launched as instruments for others to use. Others suggested they functioned as memorials, cultural lifeboats, designed to speak across the void in case the origin civilization could not survive. A minority proposed they represented a planned diaspora, a network of automated seeds designed to shepherd life outward from collapsing regions. None of the positions comforted the public. As the sun's influence intensified, 4I/ARC's transmissions grew stronger. The signal clarity allowed deeper layers to be decoded. Among the payload were encoded simulations of complex physical systems that, if replicated, might provide breakthroughs in energy generation and radiation management. Yet replication required materials and manufacturing capacities far beyond current worldwide industrial frameworks. Humanity was facing a paradox. The object offered a direction toward survival technologies, but not the shortcut to achieve them. Political maneuvers followed scientific ones. Nations began quietly reconfiguring agendas. Funding streams redirected to advanced materials, orbital infrastructure, and deep space propulsion concepts. International treaties moved from rhetoric about peaceful cooperation to operational planning, covering resource sharing, technology transfer, and ethical frameworks for using extraterrestrial information. For the first time in living memory, alliances formed around the concrete need to build durable platforms beyond planetary envelopes. The truth that provoked the most fear was not the presence of the artifact. It was the implication of broader patterns. The navigation data and decoded warnings suggested the galaxy might contain systemic threats that could compromise intelligent life on timescales a civilization could not easily detect from a single world. That realization reframed progress. Scientific curiosity gave way to strategic survival planning. Institutes that once focused on grants and publications retooled to design habitats, closed-loop life support, and distributed manufacturing that could function with minimal planetary resources. Public reaction varied from exhilaration to panic. In some places, grassroots groups organized community-level workshops about resilience. In others, conspiracy took root. The flood of conflicting information and partial leaks destabilized official messaging. Governments struggled to maintain order while also preparing for plausible scenarios suggested by the artifacts. As 4I/ARC arced behind the sun, temporarily out of sight, a global countdown began. The observation window shrank, and with it, humanity's chance to glean further details from the emissary. Teams raced to simulate the decoded schematics, to validate the physical principles embedded in the transmissions, and to scale laboratory prototypes. The objective was not simply technological achievement. It was to buy time, to increase the odds that a species concentrated on one fragile world might one day survive a class of cosmic dangers the object had warned about. In the end, what the encounter gave humanity was both a mirror and a map. The mirror reflected our vulnerability, but also our capacity for coordination. The map pointed toward possibilities that required decades of unrelenting work and cooperation to realize. Whether the world would choose to follow the map remained unknown. What was certain was this: the night the sky shifted, the conversation about the species' future moved from the margins to the center of global policy. Scientists, engineers, citizens, and leaders were forced to confront the scale of what survival might require. When the object reemerged months later, data streams resumed with renewed intensity. New modules of information activated, perhaps triggered by its solar passage. Those modules changed the calculus again and forced a generation into action. The story of 4I/ARC did not end with observation. It began a new epoch of decision-making that would define whether a species bound to a single world could become a builder of durable futures across the cosmos. The choice would not be made in boardrooms alone. It would require sustained commitment across cultures and generations to transform a cosmic warning into a workable plan for long-term survival.